So what is a distributed system, right? And the name says, right? So it is very clear from the name itself, like, it's a collection of computers or, nodes that work together uh, to form a single, entity for the end users. So in a basically a distributed system, right? So users may not know, like, from where the request is coming. For them, it will be like a single system, but we have, implemented it in such a way that the load is actually distributed across multiple systems. This is a very, basic or, core of architecture. So what are the few SLAs or like service level agreements for distributed system? You can scale very well here and horizontally. So, okay, scaling I will cover in upcoming slide. So please hold on that part. So modular growth, right? So you can actually, create your application module wise, and you can deploy it in a different machines. So you can grow in that direction. So fault tolerance is also, good to certain extent, because, if one machine is down, so you can actually still survive because your load is actually distributed. And again, the latency can be low, and it is also cost effective. So when I say scaling, right, so what is it is very important to understand, like, the difference between vertical scaling versus horizontal scaling. uh, when we send a request to the server, right, so server need to process it, right? So basically what it needs to process any request, right? Maybe it needs a computing power, and it needs maybe to some extent storage power, storage space, right? So those are the two main criteria. Now suppose, your just consider, like, you have a node or computer or machine which is serving a request, maybe, 100 requests or 1000 requests per millisecond, and you need to scale it to maybe 2000 requests per millisecond. Now what will be the feasible solution? One solution could be, you increase the capacity of the machine vertically. What does vertically means suppose you have, x amount of RAM, your increases to 2x amount of RAM, or if you need more storage, you increase the storage. That means same machine, you are increasing the capacity, right? So it is actually growing vertically. Now maybe for time being it will solve your problem, right? Because you have requirement for 1000 and it is going to 2000. But what if again, you need to support again 2000 more or 2000 more, right? So after some point you may not be able to scale vertically, or it will be very costly for you, to get that much amount of capacity in a single machine. So what generally we do is horizontal, or prefer is horizontal scaling, where you add new machines or new VMs into the system. Okay, this is where the, distributed, computing or distributed architecture uh, talks about, right? So when you scale horizontally, like adding extra machine, right, so your load will, now you can divert your load to the next machine. And when if you are getting more, that kind of request, you can keep on adding, and that adding will be on need basis. Like, you may not add no beforehand, right? When the when you don't know about the requirement, when the requirement comes, you add a new machine instead of, growing vertically. Horizontally growing is faster, okay, and it is, you can pay as in go, like as in when you are growing. That's where the cloud is helping us to grow in horizontal direction, right? Cloud model, you can see, like you can buy more VMs as and when you need it, and you can pay for it accordingly. So you don't need to do a upfront investment there. So the difference between vertical and horizontal scaling is important, and you need to understand that. And this is again a very common interview question. Okay. So next is layered architecture or tiered architecture. So this is again a coming from the distributed architecture. If you go to next step, like suppose I have a client machine and I have a server machine, right? So that is two tier. So I have a presentation layer and I have a my middle layer, or in the server or application layer. But in that case, server will be highly loaded, right? So it has to process so many things. So mainly the three layer architecture is common, where we have a presentation layer, which is the front end, the middle layer or the business layer, which is the back end, and we have a database layer, which is like your maybe your databases, how you want to keep it. So these three parts, right? So these three parts will be independent, but it will be tied together to achieve a common goal, right? So each layer will be having a specific goal here. So the presentation layer will serve the end customer or the client, right? So there might be you might be having a load balancer in between, but yeah, it is presentation layer responsibility to give the needed user experience, right? Just, and those are like physically separated machines, so you can actually scale it very well independently. Suppose you need something, no, you want to change something in the presentation layer, so you may not need to disturb the application layer or database layer, and vice versa. Like you are changing something in a database, so the presentation layer should not get affected. There is something called concept called closed and open layer here. So what is closed and open layer means is like if it is a closed layer, then you can say a layer can call only the next layer or immediate layer. For example, presentation layer should call only the middle layer or the server, right? So it should not directly call the database. So you have to that's where like APIs are now coming into picture. So presentation layer doesn't need to call the database directly, although it is possible, right? So we from a technology point of view, it is possible to connect to database directly from your UI, right? So there's you can just write some node chase code, or pure vanilla chase code, and you can directly connect to the database. But as a best practice, we want to restrict that, right? So we don't want anybody to connect to the database outside the knowledge of the servers. So database has to be accessed to the client only via the servers. That means we have to use only APIs, and we have to prove that we are authorized clients. So open layer means a layer can talk to any layer below it. So that is another architecture practice, but mostly people follow closed layer architecture because that is more secure. Okay, so this is how it is, the layered architecture. So this is a simple diagram. This is how the Azure layered architecture works actually. Okay, so you can see we have a load balancer, and we have one DMZ network layer here. I'll tell you what it is. and we have our web and business and the data layers. Okay, so DMZ network actually add an extra layer of protection, because if you see the application we are building, suppose we have created an application and we are deploying it in cloud like Azure or AWS, right? That is secure, but the client can be from any location, right? So the client connection may not be secure, right? So although our infrastructure is secure, but we may get requests from any network when we expose our application to public network, right? So DMZ network actually gives that extra layer, like you can maybe compare it with your firewall kind of stuff, which protects your application from the external world, right? So you have a load balancer will pass the request to the available DMZ node, and then it will go to the first web layer, that is your front end basically. Again, each layer you can add a load balancer. This is typically Azure architecture. Each layer you can add a load balancer, and you can have multiple VMs, and depending on the load it will redirect the request to one of those VMs, and then from there it will go to the next business or your server. The API calls will happen, and in the server also, business layer also, you will have load balancer. Similarly, database layer also you'll have load balancer. Okay, so in the database layer also, why do we need load balancer here? Because sometimes maybe heavy load, right, is coming, so you really need to balance the load between multiple databases. And sometimes maybe you may need to cater different databases, like maybe SQL, NoSQL, right? So accordingly you should be able to balance your load. And in a cloud kind of architecture, right, so you may not keep only one copy of your data base, right? So there will be replicas there. Suppose one database is down, then the load balancer should know to contact to the second instance of the database, right? This is a typical cloud kind of architecture for the layered architecture which generally we follow.